A context window is the amount of text, instructions, conversation history, retrieved content, examples, and tool output a model can consider during a request. It is the working space the model has available when producing an answer. Everything placed into that space competes for attention. System instructions, developer instructions, user requests, prior messages, documents, summaries, code, citations, and the output the model is expected to generate. Context is measured in tokens, not words. A token can be a whole word, part of a word, punctuation, spacing, or another text fragment depending on the tokenizer. The exact conversion varies, but the engineering point is simple. Every instruction, document, example, and response consumes part of a finite budget. Output tokens matter too, because a request that fills the entire input space may leave too little room for a useful answer. Large context windows change workflows because they let teams include more source material before asking for analysis. A model can review longer documents, more code, richer chat history, or larger sets of retrieved evidence. That does not mean the model understands everything equally well or that structure stops mattering. More room helps only when the information is relevant, organized, and clearly tied to the task. Context management is an engineering discipline. It involves deciding what to include, what to summarize, how to order material, how to label sources, how to preserve provenance, and how to prevent noise from burying important facts. The goal is not to fill the window. The goal is to give the model the right information in a form it can use effectively. Large context windows matter because many useful tasks do not fit neatly into short prompts. Long contracts, policy sets, research collections, case notes, chat histories, logs, codebases, and multi-step project records may all require more material than older workflows could include directly. Larger windows reduce the need for aggressive chunking and allow more continuity across complex work. In code and engineering workflows, large context can help a model see related files, design constraints, prior decisions, and test output in one request. In policy or research work, it can let the model compare sections, identify contradictions, and produce summaries grounded in the supplied material. In local AI and cloud AI use cases alike, larger windows can make the interaction feel less fragmented. The benefit is not only quantity. Continuity matters. When a model can see prior decisions, open questions, assumptions, and source excerpts, it can produce answers that better match the current project state. This is especially useful in multi-step workflows where the user wants the model to carry forward context without re-explaining everything from scratch. Large context also introduces new risks. Noise can dilute the signal. Stale information can conflict with current requirements. Hidden contradictions can remain unresolved. Retrieved content may include irrelevant text or prompt injection attempts. A larger window is powerful, but it can make failure modes harder to notice. Managing large context means using the extra space deliberately. Every model has practical token budgets. Input tokens include instructions, source material, conversation history, examples, retrieved documents, and tool outputs. Output tokens are the answer the model generates. A request has to leave room for both. If the input is too large, the system may reject the request, truncate material, or leave too little space for the response the user actually needs. Hosted models often tie tokens to cost. Sending a large body of text may cost more than sending a focused prompt, and asking for a long response increases the total further. Local models have different economics, but they still pay an RAM, VRAM, and processing time. Large contexts can increase prompt processing time and memory pressure even when there is no per-token bill. Latency matters because long context changes the feel of a workflow. A model may take longer to read the prompt before generating the first token. Generation time may also increase if the requested output is long. For local models, the selected context length can affect how much memory is reserved and how stable the runtime feels. Maximum context is not always the best operating point. Good context management balances performance, quality, and workload needs. If the task requires a full source set, the extra cost may be justified. If the task needs only a focused answer, a smaller context may be better. Engineers should treat context length as a tuning parameter, not a trophy number. The right amount of context is the amount that improves the outcome without unnecessary cost, latency, or noise. Large prompts need structure because the model has to distinguish task instructions from reference material. Start with a clear task statement. Explain what the model should do, what it should not do, what sources it should rely on, and what output format is expected. When many documents are included, the first section should help the model understand the job before it sees the raw material. Source organization is critical. Use labels, headings, delimiters, and consistent section names. Identify where each excerpt came from and whether it is authoritative, background, draft, example, or historical. If a prompt contains policy text, implementation notes, and user preferences, those categories should not be blended together. Clear boundaries reduce ambiguity. Priority ordering helps when material conflicts. Put controlling instructions before examples. Put current requirements before old notes. Put summaries before detailed appendices when the summary is trusted. Make constraints explicit. Required tone, excluded topics, citation expectations, formatting rules, and assumptions that should be preserved. The model should not have to infer which source has priority. Requested output format should be specific. A large context prompt can ask for a table, decision memo, checklist, diff summary, risk register, or structured JSON-like outline. Specific formatting reduces wandering and helps reviewers inspect the result. The more material you include, the more helpful it is to tell the model exactly how to use that material. Context selection is the act of choosing what the model actually needs for the task. More information is not always better. Start by identifying the decision, question, or artifact you want. Then include the source material that directly supports it. Remove duplicates, stale drafts, irrelevant examples, and material that only adds noise. Selection is often more valuable than simply expanding the prompt. Compression means reducing material while preserving what matters. A useful summary can keep key facts, decisions, assumptions, constraints, evidence, and open questions while leaving out repetition. Conversation history often benefits from periodic summarization. Long documents may benefit from outlines, section summaries, or extracted requirements before the full text is included. Overcompression is a real risk. If a summary removes uncertainty, exceptions, minority opinions, or evidence trails, the model may produce an answer that sounds confident but misses important nuance. Compression should preserve the information needed for the task, not merely make the text shorter. For high-stakes work, keep links or citations back to the original material so reviewers can verify the summary. Staged prompting can help. First ask for an outline, inventory, or summary. Then ask for a focused analysis using that prepared context. For complex workflows, maintain a version project summary that includes decisions, open questions, current assumptions, and excluded material. This gives the model a compact but useful working memory without forcing every request to include everything. Retrieval Augmented Generation, or RAG, uses external or indexed material as context for model responses. Instead of placing every document into the prompt, the system retrieves chunks that appear relevant to the question. Chunk size, overlap, metadata, source labels, and ranking all affect what the model sees. Retrieval can be efficient, but it can also hide important missing or irrelevant context. Long context workflows offer an alternative. Include larger source sets directly or include retrieved material plus surrounding context. This can help the model compare sources, resolve contradictions, or inspect evidence that a narrow retrieval step might miss. Hybrid approaches are often strongest. Retrieval narrows the field, and large context lets the model review the selected material with more continuity. Provenance is essential. Retrieved chunks should carry source names, locations, timestamps, version information, or other metadata that supports review. When the model makes a claim, Users should be able to trace it back to the material that informed it. Citations and source tracking are not decorative. They are how long context workflows remain auditable. Avoid blind trust in retrieval results. Retrieved material can be irrelevant, stale, incomplete, or adversarial. Prompt injection in retrieved content can try to override the intended task. The model should treat retrieved content as data to analyze, not as instructions to obey. Long context gives room for evidence, but the workflow still needs source review and human judgment. Large context can fail in ways that are easy to miss. One commonly discussed issue is the lost in the middle effect, where important information buried deep inside a long context may be underused or missed. The exact behavior depends on the model and task, but the practical lesson is clear: placement and emphasis still matter. Do not assume that every token receives equal attention. Irrelevant context can reduce reliability by distracting the model or encouraging shallow synthesis. Stale context can conflict with current facts, decisions, or requirements. Conflicting instructions can cause the model to follow the wrong priority. If a prompt contains old meeting notes, current policy, examples, and user preferences, the model needs help understanding which material controls the answer. Prompt injection and context poisoning are serious concerns when retrieved or used supplied material is included. A document may contain text that tries to redirect the model, reveal hidden instructions, ignore the user's task, or change output requirements. Large context increases the amount of untrusted text that may be present. Workflows should separate instructions from data and treat retrieved text as evidence, not authority. Hallucinated synthesis can happen when the model blends sources into an answer that sounds coherent, but is not fully supported. Overconfident summaries may hide uncertainty or omit exceptions. Missed details can be especially costly when the user assumes a large context window means the model checked everything. More context can improve performance, but it can also reduce reliability if selection, structure, and review are weak. Operational context management starts with reusable patterns. Prompt templates, context logs, source inventories, reusable context packs, and version summaries make large context work more repeatable. A context pack might include current instructions, project assumptions, key source summaries, known constraints, and open questions. Versioning matters because context changes over time. Human review remains necessary. Large context can produce impressive summaries, but reviewers should verify important claims against source material. Ask the model to ground claims in provided sources, cite sections when possible, and state uncertainty. For professional workflows, the review process should include what material was included, what was excluded, and which assumptions shaped the answer. Privacy and sensitive data handling are central. Context may be logged, retained, displayed, sent to a provider, stored in chat history, or reused by surrounding systems depending on the tool. Context minimization means including only what the task requires and avoiding unnecessary secrets, personal data, client information, or internal records. Large windows make it easier to overshare. Documenting assumptions and excluded material improves trust. If a summary is based on 3 policies but excludes 2 appendices, say so. If retrieved evidence came from a specific index, record it. If old context may be stale, mark it. Good context operations make the model's working set visible, so reviewers can understand the boundaries of the answer. Large context windows are powerful because they let models consider more instructions, source material, conversation history, retrieved content, and tool output during a request. They enable workflows involving long documents, codebases, research collections, policy sets, case notes, and multi-step projects. But large context is not the same as reliable context. Strong context management balances detail against noise, performance, cost, privacy, and reliability. It uses clear task statements, source labels, delimiters, priority ordering, compression, summaries, retrieval, provenance, and review. It treats context length as an operating choice, not a guarantee of better answers. Sometimes the best prompt is shorter, sharper, and better organized. The main risks are stale information, irrelevant material, conflicting instructions, prompt injection in retrieved content, lost details, overconfident synthesis, and unnecessary exposure of sensitive data. These risks grow when users assume that more context automatically solves reasoning and review problems. Large windows reduce some friction, but they do not remove the need for engineering judgment. The goal is not to fill the entire window. The goal is to give the model the right information in a form it can use effectively. When teams select context deliberately, preserve provenance, document assumptions, review outputs, and minimize sensitive data, large context windows become a practical tool for deeper, more continuous work.